Okay, for today, what we did before the video started was I had all the kids graph these two equations, y equals 2x and y equals 6x minus 8. And I had them see where they crossed with a calculator. Now I want you to make an XY chart. So you can set the calculator aside. I mean, don't like close it forever or anything. But go to some scratch paper or in the notes for today and make an XY chart because I want you to see why the answer is 2, 4. Okay? I want you to put in the numbers 1, 2, and 3 on both functions. And I think you'll logically see where the answer has to be. If you put 1 in this function, you put it here, and you get 2 times 1 is 2. That's one of those top 20 skills, is finding points on a line. Ian, have you put in 1, 2, and 3? You. Okay, go ahead and get going on that. I'm going to ask you to put in 3 for me right now, though. This right here, we're putting a 3 into this function here. So tell me what to do. Okay, I'm going to come back to you in a second, so get back focused with me. We're putting these numbers into these functions. So, all right, I'm going to ask Megan to tell me, when I put 3 in this function, what do I get? Because the 3 goes here, and then I have 2 times 3 is 6. Y equals 6. You are correct. Ian, would you put in the 2? And the 2 goes here. 2 times 2 is 4. There you go. Okay, now we go to the other function. Stella, when you put a 1 into this function, what do you get? 1's going right here, Stella. What do you get? I'll walk you through it. Oh, -2. You are correct. Okay. And then the next one, Jack.
4.
And we knew 2, 4 was going to come up. Why? Because that's where they cross. They both have 2, 4 as a point. So this way would work. You could find the answer this way. Just keep finding points until you're like, that's the one. They both have 2, 4 on them. If I put in 3 on this one, Liv, what did you get when you put in 3 right here? 6 times 3 is 18 minus 8 is 10. 3, 10. All right, but that wasn't the key point. The 2, 4 was because they both shared 2, 4. All right, now what's the new thing for today? It's called substitution. So some people like to have their steps written out in words. So this is what it would be if you wrote it out in words. You solve one of the equations for one of the variables. Then you plug this back in the other equation. It's called substitution. Then you back solve. All right, let me show you that in action. You know that one we just had, y equals 2x? Would you please get that on a nice clean area where you can work with it again? And y equals 6x minus 8. Everybody write those out again somewhere where you can work with it. Carl, your hands, oh wait, it looks like you're distracted. Come back quickly. Ian, you had this and you have this. From what I just said about substitution, you can put the black one into the blue one. Do you know where? It says y equals 2x.
Whoever said that, yes, thank you for reminding.
So I replace y with what?
With 2x.
Yeah, because it says y is 2x, right? So 2x, and look at that. I've got an equation. 2x equals 6x minus 8. Do you know how to solve that? 2x equals 6x minus 8. Looks a little weird, but I can solve it. I just subtract 2x from both sides. I know that freaks people out sometimes that you get 0. But don't be afraid of 0. It's just a normal number like all the other numbers. And then I'm going to add 8 to both sides, and I have 8 equals 4x, x equals 2. Look at it, I didn't even have to graph it. and I got x equals 2. It's the same answer. Makes sense. We already graphed it. We knew it was going to come out to 2. Okay, that's the algebra way. You get a lot of algebra on that way. Do you like the graphing way better? Well, sometimes on the test, they're going to say graph it. See where they cross. Sometimes they're going to say solve it with substitution, which was that. That was called substitution. But the other thing is, it's supposed to be 2 comma 4. How do I get the 4? Well, I go back to the original problem, which was these two. And now that I know x is 2, you can substitute again. X is 2. Look, y equals 2 times 2. Y equals 4. All right, that's called substitution. I'm going to give you another one that's just like it. You ready? Y equals 5x. Two x plus 3y is equal to, let me think for a second. $17. Could you graph both of those and see where they cross? Not easily, but you could if you solved this one for y, but let's not do that. Let's not graph them, because there's an easier way. It's called substitution, the thing I just taught you. Do you get this y shows up somewhere? Do you see it? It's right here. What can you replace the y with? 5x, because it says y is 5x. So I can replace this y right here. This is me erasing the y and putting in a parentheses, that's important, and dropping in 5x. That was called substitution. I substituted out the y and I put in 5x because they're equal. All right, now I got 2x plus, what's 3 times 5x? 15x equals 17. And then I got 17x equals 17. So what's x equal to? 1. Who had 1 before I even said it? Couple people. Is that the final answer? Well, yeah, x is 1. That's it. But what's y? Well, look at the original equations. The red one and the blue one. Can you put the 1 into either one? Yes. But this one's easier. Put the 1 in here. It says x is 1. Use substitution. Where you see the x, you put a 1. What's y equal to then?
5.
Yeah. X equals 1. Y equals 5. You know the faster way to write that? 1 comma 5. And that's where they would have crossed if you had graphed them. Behold substitution. That's called solving with substitution. All right, I think we're almost seriously ready to just give you some problems and say solve them. But I think we better do a little more work, because what if it's a harder one like this where there's nothing solved already? Like I don't know what x is and I don't know what y is. Well, and the first thing you do is solve for one of the variables. I don't care. What's easiest? They call it the loneliest variable. The easiest things to solve for, in this case, you could easily solve for x or y. It wouldn't be hard to solve for either one. But being honest, I'd rather solve for x because I'd just rather subtract y from both sides, so I'm going to go like that. And look, I solved for x. I subtracted y from both sides, and I have x equals 2 minus y. Would you please solve that the rest of the way and put this wherever x is and solve for it? This goes where x is. Remember, x equals this. Pausing for a second. Okay, so we've got x is 2 minus y, so I substituted it in. For x, I put 2 minus y. Now I'm distributing this out. You should have had 8 minus 4y minus y equals 4. Kennedy, what's the next step? Good, what do they make? 8 minus 5y equals 4. Good. Cyril, what do we subtract next?
Please subtract 4 by 8.
Yes, we're going to take away 8. Okay. Why did I do that? Because now I'm down to just negative 5y, and I can always divide last. What's 4 minus 8? Negative 4. Ian, K, finish.
5 by 5.
Yep. I had the sad number of people that left like 2 negatives in a problem. Do you guys know what's supposed to happen? Cancel 4/5. Raise your hand if you had 4/5. Sweet. Now, if we really wanted the final answer, we'd have to go put that 4/5 back into the problem. And if y is 4/5, I'm going to clean this back up again to what it was to start with. If y is 4/5, I'd have to put it where y is, because it says y is 4/5. So I'm going to put a 4/5 right there. But then that's a pain because it's got a fraction. Oh, I can't do fractions. Yeah, you have to do fractions. In this class, in the class above it, we use fractions. So can't be scared of them. I'm going to take away 4/5 from both sides. Minus 4/5. You should be able to think this through. What is 2 but take away 4/5? Well, it's kind of like 1/5. But it's more than that. 2 minus 4/5. Somebody's going to have it. And seriously, nobody in the room do 2 minus 4/5? It's a little scary. All right, I'm going to help you. I like what she said. 2 over 1 minus 4/5. And then we need a common what? Denominator. So I'm going to make this have a 5 denominator. Now that's 10/5 minus 4/5. And thank you, Avia. That helped a lot. 10/5 minus 4/5 is 6/5. And that's your final answer. If you said 1 1/5, it's the same exact thing. All right. So that again was 2 minus 4/5. Would you have been able to do it? Well, really you just had to make them both fractions and get them a common denominator, and it's not that scary. Common denominator was 5, so we go times 5, and then they have a denominator that's the same, and then I could just put them together. 6/5. All right. So this is called substitution. It's not solved for anything. What's the loneliest variable? What's the variable that's easiest to solve for? I could see solving for that, but it's kind of a pain because you'll get negative y, and then you got to make both sides opposite. I'd rather solve for this one. Do you see why it's going to be easy to solve for the x? All right. So everybody find this problem and solve for that x I just circled. Lily, what are we going to subtract from both sides? You always start by add or subtract, so thank you for trying. Subtract 2y from both sides. Then x is alone instantly. That was the fastest thing we could do because 2y and negative 2y will cancel. And now what's x? Nico, x equals what? One kid said negative 2y plus 3. They're right. The other kid said 3 minus 2y. Also right. Do you get that this and this are the same? Either way works. That's when you have to have it in y equals mx plus b form. But I do like the y first, but you don't have to. You could have said 3 minus 2y. It would have been okay. All right. So now this is what x is. Do you see x in that other equation that we haven't touched yet? Do you see the x? Right where that x is, we're going to put, not leaving quite yet, soon though, we're going to put negative 2y plus 3. Negative 2y plus 3. We're going to finish this one before we go, so stay with me. Multiplying this out. Ian, multiply these by 2 and tell me what you get. Ian in the back.
Negative 4, 6.
Negative 4, this is a y. Can you read the board? We're timesing this by this and this by that. Plus 6. Okay, good. Minus y equals 4. That's this equation rewritten over again. Now the negative 4y and the negative y make negative 5y plus 6 equals 4. Then we're going to subtract 6 from both sides. Every now and then math teachers go up. Not usually, but negative 5y equals negative 2. I'm almost done. What's y equal to? Negative 2 over negative 5. So that's the same as 2/5. And there's your answer. All right, we'll resume this after lunch. And we're back from lunch. A quick reminder, just a 2-second reminder. If x equaled 2 and y equaled 3x plus 7, where could you put that 2? Mallory, where could you put the 2? In the place of the x. The 2 could go where the x is. And here's the x right there. So you could put a 2 there. Everybody tell me what you get when you put a 2 there. Is that 32? No, that means 3 times 2. Grace, what do you think y is? Y equals 6 plus 7. What's that? 13. Y equals 13. Raise your hand if you had 13. Okay. So then if x is 2 and y is 13, the place this would have crossed is at 2, 13. All right, let's get another nice simple one. Y equals 7 and y equals 2x, let me think, plus 3 plus 1. Solve with substitution. Write that one down. Substitute the one into the other. And I know this one's kind of easy, but it's good to see all different kinds. Easy ones, medium ones, hard ones. If y is 7, whenever you see a y, oh, there's a y, I'm going to put a 7. Then I'm going to subtract 1 from both sides, and I get 6 equals 2x. What's x got to equal? 3. Raise your hand if you had 3. Good. All right. Here's a medium step up. Like, it's not super hard, but it's harder than that last one. Y equals 2x. And 3x plus 2y equals, let me think. 2. 5. There we go. Figured it out. Now I made it so that it would hit at a lattice point. Otherwise, if you would have graphed it, it wouldn't have. If I hadn't been careful with that 5. All right, so, well, that's a lot harder. No, it's really just about the same thing. Instead of putting in a 2 for y, you're going to put in 2x. So do you see the y down there? Avia, what am I going to replace the y with? What's y equal to? 2x. So put it there. And now look at that equation. It's only got x's. It's got 3 x's, and that's actually 4 x's because you'll multiply those. And what's 3x plus 4x make? 7x. 3 and 4 makes 7x equals 5. And I'm almost done. Divide by what? And you get x equals 5/7. And that one didn't work out as nice, but how many of you got 5/7? Raise your hand if you did. Okay, good. If I had to finish that one, I'd just put the 5/7 back here. And I'd put 5/7 right there, and it would tell me y equals 2 times 5/7, which would be 10/7. Do you guys get that that 2 is like 2 over 1? So then it's just 2 times 5 is 10 over 7. All right, now let's get to some problems that are on this page. Everybody get to this one. It's in your notes. Y equals -2. 4x minus 3y equals 18. If you can concentrate with me for like 2 more minutes, we can get through this and we'll be on to your worksheet. Ready? Nico, do you see a y in the lower equation? And then can you swap in the right thing? And you put the -2 where the y was. Nice. And then any one of you could have easily solved that from there. This was an easy one, wasn't it? Because y was -2, so we put the y and we put a -2 there. 4x, there is 2 negatives there, makes that plus 6. And I'm subtracting 6. 4x equals 12. Ooh, that's the one I can do in my head. X equals 3. Do you get how you use substitution? So what was yesterday? Was graphing. Could we have graphed these two? Yeah. But the bottom one would have been a pain to graph because your calculator always wants it to be y equals. You would have had to solve for y. You could have graphed both of them, and guess where they would have crossed? At y equals -2 and x equals 3. So 3 comma -2 is where they would have crossed if we had graphed them. Okay. This one. Yuck. Is there something that's solved? Is anything solved? Is y solved? Is y alone in one of the equations? Then y is solved. Y is solved. This is what y is. So where do you put it? Where y is. Three, and then where y is, I put -2x plus 9. Then copy the rest of the problem. -2x equals 11. And then again, it's just plain old multiply things out, solve a normal equation from there. But that one had something that was solved. Y was alone. Just imagine for a minute that this had been -9 plus y. Then nothing would have been solved. But I would have just got rid of that by adding 9 to both sides, and it would go over there. So y's alone. So you just got to get something solved first. And then you stick it in the other equation. That's called substitution. All right, here's one where something is solved already. Is x solved? Nope. Is y solved? Yes. So you can see that this one, I know what y is. It's that. So wherever you see y in the other equation, you'd put this. I won't even have you do this one, but I think you get it, don't you? This is substitution. All right, last one. Just set it up right. Substitute the right thing in the right place. Don't even solve it, just substitute it. I know by this point, your food coma is probably about to begin. So just get it set up right. And then we'll get you into the homework. I always like to do the first couple problems of the homework with you so you can get started. Megan, did you find x somewhere and so you could stick in negative 3y minus 4? So I'm putting a 2 and in a parentheses, negative 3y minus 4. Tell me what I should keep. What's the next part? Good. Then the blue part, you actually need to do more. It's this. Megan, can you do that part?
Negative 6y and negative 3 plus 6y equals negative 8.
And I want to finish this one because it's weird. What's 6y and negative 6y make? Aren't they just like opposites, so they just disappear? And it's true. They disappear. What the heck? You might have never had that happen until now because you're in Algebra 2 class. But when all the variables disappear and you're left with something that's true, what that means is that all numbers work. All numbers work in your original equation. What that really means is if I graph this and I graph this, they're exactly on top of each other all the time. They are in the same exact spot. Because like if I graphed this and I came up with, here's one of them, and then here's the other one, it's right on top of this one. So what's the solution? Everything is the solution. Could it also happen that you graph two things and they never touch each other? If they never touched each other, they'd be like this. Then they're called parallel. And then there's something called no solution. So if you get one where it's weird and all the variables drop out, if it's like x plus 3 equals x plus 3, that's a true statement. I just subtract x from both sides and it's like 3 equals 3. If you get left with, wait, 3 equals 3. If you get left with a fact like 3 equals 3, then that meant they were right on top of each other and everything works. Every x would be an answer. But if you're left with something that is not the same, like let's say I put a 5 here, and then it's 3 equals 5 when the variables drop out. Is it true that 3 equals 5? No, then that means there aren't ever any solutions, and those two must have been parallel lines that would have never touched. If you graphed them, they would have never touched, so there's no solution. If you come up with a false statement, it means nothing ever works. If you solve something, x plus 3 times, or 3 to the second, well, it's going to be the same thing. I take away x, I get 9 equals 3 to the second, and that's just a fact. 9 is 9. Is this the kind where everything's the answer, or nothing's the answer? Everything's the answer. If this had been a false fact, like 9 equals 8, then you'd say, nothing's the answer. So you learn something new there. If you solve and all variables disappear, if you're left with something true, then everything's the answer. When it's true, everything works right. No matter what number you put in, it would have worked. And if you're left with a false statement, then that means nothing works. You got to get used to that one. I teach honors pre-calc, and in that honors class, and in regular pre-calc too, almost every test has an answer where the answer is there's no solution. Got to get used to the idea that there are answers where there is no answer. It's kind of like if I gave you this graph and I gave you this graph and I said, where do they touch? And you'd say, they don't. There's no solution. So how about if I make another graph that's right on top of this graph? Well, then I'd say that everything is the solution because they touch everywhere. Okay, so you got to get used to both of those kinds. All right, we've made it to the end. Everybody find the worksheet that is set. I think it's a Schoology quiz, isn't it? All right, is it enabled? Like, can you open it? Excellent. Nico, could you read me the first one? All right, so we're doing substitution. That was the whole point today. So wherever you see the y, you put a 5x. I see the y here. I'm putting a 5x there. And now, it's just an easy little equation. Avia, could you tell me what you would do next?
I think you would distribute the two.
Okay, so 2 times the 5x, what's that make?
That makes
10x, put it with the 4x, and you get 14x equals 7. Wait, 14x equals 7. All right, this was 10, this was 4, that made 14. And then,
5,
by
14,
final answer.
x.
A lot of people probably thought it was 2, but it's not 2.
7 over 14, but you can
Simplify 2.
apply it to 2 over 7.
Nope.
Wait, no.
7 times 1 over 7 times 2, and then the 7s will cancel, and you have
1 over
1/2. 7/14 is 1/2. There you go. Food coma has begun for you. All right. So that's a start. And I'm not going to do all the homework problems for you, but does number 2 get really tricky? Or can you see what to do on number 2?
2 makes sense. 3 is
3 is weird. Anyone read me 3?
sure. Y equals 2x minus 1. Y equals 3x plus 1.
Well, I can tell right now that these are not parallel to each other. And so they can't be either the same line, and they can't be like 2 lines that are parallel and never going to touch. So I know these touch somewhere. If their slopes aren't the same, then they have to touch somewhere. Otherwise, if their slopes were the same, they could never touch. But these have to touch somewhere. So I know it works. Do you replace the y with 2x minus 1? So I'm going to put the 2x minus 1 right there, because that's where the y was. 2x minus 1. And then it's just solving what's beneath that line there. Let's solve that. I'm going to subtract 2x from both sides. And I get negative 1 equals x plus 1. Is x alone yet? No. Mallory, what's the next step?
minus 1.
Minus 1. Negative 2 equals x. Oh, that's pretty much it. Except they're going to want both points. You know, like I got the x, but they want to know what the y is. Because if it's a point like x comma y, we know the x part is negative 2, but what's the y part? Well, I go back to this, and I just said the x was negative 2. So I can put negative 2 right there. And that tells me y equals whatever that is, and that's your final answer. All right, I think you started. Now, if you have individual questions, please bring them on up. I'll be happy to help you. That's all I got for the video for today.